Assalamualaikum warahmatullahi wabarakatuh. Right, so quantum physics. So what is important? First thing, you need to know about black body. What is black body? So black body, a body ataupun an object emitting electromagnetic radiation. And this electromagnetic radiation determined by its temperature. So here are examples. Okay, filament lamp. So here is the filament. At certain temperature, at a given temperature, only we will see the filament light up this color. Same goes for charcoal. Always black, but at a temperature, we'll see the color emitted. And about stars, okay, we see stars. Kita nampak bintang tu. So the stars that we see actually they have reached certain temperatures that enables it to emit light. Okay, so for this example, this one, so we see Betelgeuse and Rigel. This figure shows two stars. Betelgeuse appears to glow red. This one, Rigel, looks blue. Which star has higher surface temperature? So in order to answer this one, quantum theory of light. Okay, so you need to remember ini je, macam ni. So at cool temperature ataupun if the object is cold, it has low frequency. If it is hot, it has high frequency. What does that mean? So that means, for this one, higher surface temperature. So if it has high temperature, that means high frequency. And then this one, you kena tahu lah, you kena hafal. Macam mana you hafal? So if I tell my students, they can use this one lah. Gorilla don't use vape in mother's microwave, mother's room. Gamma rays, X-ray, UV, and then visible, and then infrared, microwave, and radio waves. So these are the 7 that you have to know. 1, 2, 3, 4, 5, 6, 7. So from here, okay, and then you need to know lah, visible light consists of 7 colors. This one, 7 electromagnetic radiation, including visible light. And visible light pula ada 7 colors. The Roy G. Biff tu. So from here we see at this direction, the frequency increases. So this one has high frequency. Red has highest frequency compared to violet. So back to this question, red has high frequency. So high frequency means it's a hot object. Jadi, which star has higher surface temperature? The red one, because high frequency. So the answer is Betelgeuse. Alright. Okay. B, C, and D is incorrect. Okay, so these are other examples of black bodies. Okay, and anything that has a temperature, then for example, so this is an example for you to understand more. If you heat up a piece of iron, it glows. Okay, if you actually look at it, the light emitted has lots of different wavelengths. We see black color, we see reddish somewhere, and then oranges, and then yellowish. So the distribution of wavelengths, okay, and remember, colors have different wavelength. Jadi just now tadi we may get this spectrum. Right, then the distribution of wavelengths follows a very characteristic curve. So this is the curve, and for each temperature there's a unique curve characterized by the peaks. So at different temperature, the curve will change its shape. Alright, and then what about the sun? So the sun, in which there's stuff exploding in the middle of it, so the sun also is the same. So it gives off the same profile as hot piece of iron. Alright, and this is another example. We have 3 different balls. Okay, so the black balls absorbed all the black body, absorbs all the light color, but red absorb all colors and then reflect red wavelength ataupun red light. And white, what about white? White does not absorb any, it reflects all of the colors. Okay, and then you need to know the second thing about quantum. You need to know about okay, we have 2 types of spectrum. First is continuous spectrum, and then second we have line spectrum. And it's very obvious, very distinct. Continuous means ni tengok ni, continue, no gap separation between each color. So you cannot identify exactly where the green starts. It mix up kan. Same for yellow and red. Kat mana red starts? Kat sini ke sini? So it continuous. So that's continuous spectrum. What about line spectrum? So the line spectrum shows electromagnetic or specific frequencies. Every line is caused by a transition. Okay, so it's very, very distinct. Non-continuous. Then we have a formula, quantum of energy. So we have Planck's quantum theory. So the theory says that, so what is quantum of energy? It is discrete energy packet and not a continuous energy. So energy tu as if it is in a packet. 1 packet, 2, packet 1, packet 2. It's not continuous. So last time we learned about wave, it is a continuous energy like that. But quantum says a discrete energy packet and not a continuous energy. So last time we learned about light. Remember kita belajar tajuk light kan. Okay, masa kita belajar tajuk light tu, we just know that light is a kind of wave. Remember? Dalam tajuk wave pun kita ada light reflection, light refraction and so on. So light behaves as a wave. But in this topic, kita tambah lagi pengetahuan deeper about light. Okay, light also exists in quanta, quanta and photon. Light also is a particle. Okay, energy size of the radiation depends on frequency. So Planck's quantum theory says that energy depends on frequency. So hence this formula. H is a constant. You don't have to remember this one. But from this theory, we know that energy is directly proportional to frequency. If we have higher frequency, remember about the stars just now? The higher the frequency, the higher the energy. Okay. Now, don't forget this formula. V equals to F lambda, which is given in the formula sheet. And V ni is the velocity of light ataupun speed of light. V equals to F lambda, and V is the velocity. But for light, light travels in the air ataupun in vacuum. The speed is 3 times 10 to the power of 8. So this value is constant. Jadi kita guna huruf C. Therefore, this V ni kita change into C. The rest remain. And from this equation, we rearrange, we get F equals to C over lambda. F. Here is the F. So here is the F. So we substitute F with this one. Ni F. So we also have this formula. Actually, these are the same. Just that this one kita substitute F. Okay, example question. Okay, ready to answer this question? Which of the following graph shows the relationship between the energy and the wavelength of a photon of electromagnetic radiation? So just now we have looked at the energy and wavelength. So just now we looked at energy equals to HF. Here energy directly proportional to F. So F increases, E increases. But C equals to V equals to F lambda. That's also F equal lambda. F is equal to C over lambda. Okay, rearrange. And then we substitute that. So from this equation now, we see that E is inversely proportional to wavelength. Tingkat berbeza. Ni kat atas, ni bawah. Jadi, dia inversely proportional. That means if you increase the wavelength, energy decreases. So this is the answer. Okay, next, in this topic, you need to know about wave-particle duality. Duality means, okay, wave particle. Light behaves as a wave. Light also behaves as a particle. Okay, so if light, why scientists says that? Light behave as a wave? What's the proof? Okay, when experiment is carried out, light tu dia ada ciri-ciri, it can be interfered. So maksudnya interference pattern obtained. So kita belajar tajuk wave kan? Tajuk wave, a phenomenon of waves, reflection, refraction, diffraction, and interference. Okay, So interference pattern tu berlaku when we have light. So maksudnya kita letak laser, kita dapat dua gap kat situ, and we can get interference pattern. Now, at the same time, we can get photoelectric effect. Electrons being emitted from the surface of metal given the incidence of radiation of a sufficiently high frequency. Okay, so light is a, what do you read? What do you see? Light is a particle. Do you see that? And light also is a wave. See? Alright. Alright. So that's ini sahaja yang you kena tahu tentang wave particle duality. So these are the two experiments. Interference. Ini show the photoelectric effect. These are the combination of the two. Okay, and then we learn about de Broglie's wavelengths. Okay. So this is the formula, de Broglie's principle given in the formula sheet. And then we have this equation. Ni pun sama. Okay, this is an example in the textbook. Right. Kita tengok example question. Which of the following graph illustrate the variation of the de Broglie's wavelength with momentum for an electron? So how do you answer this one? So kita tengok tadi formula P equals to NHF. What's the P? So P is this is the de Broglie's wavelength. Lambda equals to H over mv. Lambda equals to H over mv. Okay. MV, you remember you learn dalam topik yang awal-awal, momentum equals to mass times velocity. So that's the momentum. Okay. So ini sebenarnya H over momentum. Okay. So what's the from here, dah tengok dah. What's the relationship? If you increase the momentum, wavelength decreases. So the answer is D, determine. Okay, kita tengok, and then kita tengok photoelectric effect. Okay, what does photoelectric effect? Effect apa? Photo and then electric. Kita dapat electric. Ada photo and then we get electricity. Okay. Okay, so just now we learned about wave particle duality. So, ada electron and then behaves as light. Okay. Now, this is how we get the photoelectric effect. Kita ada what do you say? Circuit. This circuit, actually this is not connected. Dia adalah incomplete circuit. If you notice this one, battery connected to an anode, and then ada empty space, vacuum. Vacuum macam empty space, tak bertemu ni. And then kita ada metal. So you can imagine like this lah, macam as if all these tak ada. It's like that, macam tu sebenarnya. Tak ada apa-apa. Dia tak berhubung lah. Dia incomplete circuit. So for electricity, we need to have a complete circuit, kan? Alright, and then this metal connected to cathode, ada milliammeter to read the reading of current. So how do we get current? Macam mana current is produced? Or how do we get electron flows? So first of all, we need to have a photo ataupun light source. Light source. Okay, when the light hit the metal, when light hit metal, okay, at certain frequency, okay, when the frequency ataupun the energy is high enough, the metal emits electron. Emits electron. So when electrons are emitted, all the electrons are attracted to the positive or the anode. So we get electric. So that's why we call it photoelectric effect. So the metal is illuminated with a certain light, and then electrons will be emitted from the surface metal. The movement of electrons towards the anode, so that is when we get current. So that's why we nama dia photoelectric effect. Okay, when you have understood this, boleh imagine kalau soalan tanya tentang photoelectric effect, you can recall this diagram to help you remember ataupun understand. Next, when we have understood this, we can do analysis. Okay, and okay, nampak tak kat sini we have emitter. Emitter is to measure current. Okay, so we can also measure the voltage. So we have two different graphs here. So this one graph current against V voltage, and graph of VA against wavelength. Okay, so what is this VA? So this VA is activation voltage. So what do you see from the graph? So ni nampak dia tidak directly proportional, dia increasing linearly. Maksudnya the graph cuts the x-axis. And this one, the x-intercept ni is the value of activation voltage. Jadi kalau kita buat untuk banyak-banyak color, this one contoh yellow light. And then we carry out for a few different colors. Contoh hijau. And then kita buat untuk biru. Ni contoh je lah And then yellow. Okay, kita dapat different values of VA. So kat situ kita plot pula VA against different wavelengths. Jadi daripada situ kita dapati the relationship is different color, different wavelength has different activation voltage. Ataupun kita kata dia inversely proportional lah. If you decrease the wavelength, blue light semua tu, so blue light, yellow light, green, the activation voltage higher. Tapi kalau red, yellow, the activation voltage is lower. Maksudnya you need a voltage dia low saja. Voltage low saja pun dah dapat electron. That's what it means. Okay, I think we stop there. Okay, we'll continue next class.